Okay, continuing on with our series on how to graph trig functions, let's do something a little more complicated this time. We have y equals 2 times secant of 3/4 times t minus pi over 6. Looking at our analysis here, we see that there's no vertical shift. The phase shift is to the right by pi over 6. There is a vertical stretch factor of 2. Remember that amplitude has no meaning for secant, cosecant, tangent, and cotangent. We also see that b in our equation is 3/4. Period is going to be 2 pi over b, which comes out to be 8 pi over 3. This equation is going to have vertical asymptotes wherever cosine is equal to 0 because secant is 1 over cosine. Cosine of theta equals 0 at pi over 2, at 3 pi over 2, negative pi over 2, negative 3 pi over 2, or in other words, theta equals pi over 2 plus pi k. And we're going to take this entire angle and plug it in for theta. So we're going to get 3 over 4 times t minus pi over 6 is equal to pi over 2 plus pi k. Now I just have to solve for t to find where this equation has its vertical asymptotes. To solve for t, I'm going to divide both sides of the equation by 3/4, add pi over 6 to both sides. I'm going to leave it to you to figure out if I've done my algebra correctly here, but I'm going to get 5 pi over 6 plus 4 pi over 3 times k. Remember, k can be any integer. Okay, that's where my asymptotes are going to be. So I'm going to start here at 5 pi over 6, draw in an asymptote. Add 4 pi over 3 to it, the next asymptote is going to be just off my graph over here. Start here and subtract 4 pi over 3, I get an asymptote here. Subtract another 4 pi over 3, I'm going to get another asymptote over here. Okay? Now, remember that the distance between the asymptotes is a semicircle. For secant and cosine, that semicircle is going to be between 3 pi over 2 and pi over 2. Okay? And halfway between the asymptotes, halfway through my semicircle, I always get something interesting. Secant equals 1 there. When I multiply it by 2, I'm going to get a 2. And how did I know it was positive here? Well, remember, the parent graph of secant has a positive value on the y-axis. And this one is shifted to the right by pi over 6. There it is, positive. Okay? Okay. Halfway between these asymptotes, I'm going to have a negative value, and likewise over here halfway between these asymptotes. Okay, also if I take my semicircle, or the distance between my asymptotes, and divide it up into a sixth, a fourth, and a third, I'm going to get my special angles. So take this distance, divide it up into a sixth, a fourth, and a third, I get my special angles. A sixth of the way in from the asymptotes, secant is always going to equal 2. When I multiply it by 2, I get 4. So a sixth of the way in, I get 4, and 4. Over here, I'm going to get negative 4 a sixth of the way in, and negative 4 over here, a sixth of the way in. Here I get negative 4 and negative 4. A quarter of the way in, secant is always equal to the square root of 2. When I multiply that by 2, I get 2.828, 2.828, negative 2.828, and negative 2.828. A third of the way in, secant is always going to equal 2 over the square root of 3. When I multiply that by 2, I get approximately 2.309. And over here I'm going to get negative 2.309. And here I'll get negative 2.309. Now that I've got all of my points, my special angles, graphed nicely, it's a simple matter to fill in the dots, connect the dots, fill in with the rest of the graph, and it's going to look like that.